Hello everyone. Let's have a look into an emerging topic, an effective approach to 5G wireless network virtualization. We are currently in the 21st century, an era of technological advancements. Day by day, we are having new discoveries or inventions, and what we consider as the latest technology today will be a distant past tomorrow. In short, change is the only thing that will not change. As far as mobile communication is concerned, the growth from 1G to 4G was tremendous and rapid. And we are at a stage where we need another evolution in this in order to meet the fast growing demand for mobile services. And here comes 5G, the future of mobile communication. The future 5G is expected to offer a very high data rate of the order of tens of megabytes to tens of thousands of users. It will provide unbelievably fast broadband speed, but more importantly, it will have enough capacity wherever you go to perform every function you want without a drop of speed of connection. One of the main advantage over 4G is the high spectral efficiency. It will also provide better coverage and enhanced signaling efficiency. As we can infer from the graph, over the years, there has been a tremendous increase in the traffic due to wireless network. It is estimated that by the year 2020, the traffic carried by the wireless networks will be around 6 times greater than in 2014. The features and requirements of different services are diverse in 5G. In order to cope up with this heavy network traffic and user demand, we suggest wireless network virtualization as an effective approach. What is wireless network virtualization? So basically, let's see what is a network virtualization. Network virtualization is the process of combining network resources and functionality of hardware and software into a single software-based administrative entity. In this, each are independent from the other and can be assigned to a particular device or server in real time. Each channel is independently secured and each subscriber has shared access to all the resources on the network from a single computer. Network can be virtualized in two ways, wired or wireless. There are few standards available for wired and they are already in use. Our current interest is wireless network virtualization to meet the explosively growing demands for mobile service. The existing approach for wired can't be applied to wireless because of the unique characteristics. Okay, let's see why to virtualize this wireless network. So this is an extension of wired network virtualization. It enables segregation of traffic. One of the major reasons is the spectrum sharing. As we all know, spectrum is a valuable resource and is quite costly. Even if someone manages to buy that, up to what level it can be utilized again depends on regulatory bodies. If we are able to have spectrum sharing, it would be much more beneficial to everyone, like decoupling the operators from cost of infrastructure ownership, decoupling the service providers from operators. Users can simply subscribe to services. And yes, users will be free of operators. The virtualization of wireless networks can be realized by sharing core network, radio access network, or wireless resource. So the first is the core network. In this, multiple RANs belong to different network operators. Due to operators' deployment, different nodes or part of the common core network can be shared. The next is the radio access network. Here, different operators may share common RANs instead of radio frequency. RANs owned by different operators may cover different geographical areas. The last is the wireless resources like spectrum. The licensed spectrum can be shared by the operators, probably by pooling the spectrum. So in the basic WNV architecture, there are three planes: the data plane, the control plane, and the cognitive plane. The first is the data plane. This is responsible for transmission of user traffic via virtual network. The next is the control plane. This has the charge of integrating all the available RANs and resources together and slicing them into virtual networks which are independent and isolated to guarantee no interference and conflicts among users. The last is the cognitive plane. This captures the state information like state of services, network resources, and user requirements from user equipments, RAN, and service providers are transmitted to the control plane. Now, we will look into one of the suggested effective approach of wireless virtualization network, which is hierarchical virtualization control scheme. This will have a centralized control plane and self-governing cell communities. So this basically has three main features. One is cell clustering. Certain number of cells show similar characteristics like traffic features. These cells are divided into communities for resource utilization and hierarchical control scheme. The second feature is the control scheme. The idle wireless resources from other communities with light load can be transferred to the communities with high traffic requirements to satisfy user throughput demands. After peak time, the radio resources can be returned to the resource pool. The third is control signaling. To provide services to users, the virtualized wireless network and user equipment need to be informed of the resource allocation and channel condition to establish the wireless data transmission connection. There are two approaches of control signaling: in-band and out-of-band. In in-band, this does not need any specified resource allocation for control channel, but it may cause interference. Out-of-band. Here, a dedicated band is used for control signaling and transmission. The allocation of resources for control channel decreases the resource utilization. So this is the overall functioning of the hierarchical virtualization control scheme. At first, user equipment send request to the virtualization control with measurement report gathered using cognitive plane. It then processes the request and send the feedback back to the user equipment with available resources. If the user equipment meets the feedback sent by the control, it can ask RAN to establish the connection. After that, RAN will inform the virtualization control regarding the connection establishment to update the availability of the resources. Next is adjustment phase, in which periodical measurement report will be sent from user to the control. That is, user is requesting for more resources. In that stage, the control has the right to take the decision whether to allocate more resources or not. It will take a decision based on this and will send an acknowledgement back to the user and RAN. To showcase the performance efficiency and how well this scheme works, we can consider two cases. The first is the spectrum virtualization. Here, the operators contribute their licensed spectrum into a spectrum pool. The spectrum is allocated based on a technique called advanced spectrum management. The ASM server is embedded in the hierarchical virtualization control, equipped with functions of periodically estimating the traffic requirements of each cell and dynamically adjusting the spectrum slices to each cell.
The second use case is flow level resource utilization. It requires different sets of flows to be allocated to the appropriate virtual network. Based on network load condition, it can also adjust the size of the flow slice. The flow division is equipped with virtualization management. Here, the traffic flows are divided into packet blocks. These blocks are labeled with packet sequence number and virtual resources being carried. Without knowing which virtual resources are allocated and how the virtual networks transmit, the MMTs on UE reconstructs these packet blocks according to the sequence label and merge them into the original service flow. Multi-flow transmission system comprises of service resources, multimode mobile terminal, and flow scheduling server. The flow scheduling server is responsible for dividing the service flow into multiple dedicated slices for different virtual networks to carry. Let's see how these test cases are performed. For the first case, we consider two cells each having 4 user equipment. After spectrum virtualization, the total spectral utilization percentage has been increased nearly by 30% compared to the case without spectrum virtualization. This demonstrates the flexibility of spectrum virtualization and the efficient utilization of spectrum. The second was flow level virtualization. Here, online playback was taken as an example. Cognitive plane is a key enabler for smooth transmission. Multi-flow with cognitive plane acts as a self-adaptive controller which can handle feedback information and allocate reasonable bandwidth. The outcome was lower package loss rate with much better quality of service. With this, we can say that the proposed hierarchical virtualization control proved to be beneficial for future wireless network virtualization. But we can't stop there. There are so many requirements to be considered for the same. The factors to be considered are: we need a better design of wireless resource management, a better control signaling, an efficient computing part, and enhanced storage resources, and finally granularity for efficient slicing of infrastructure and resources. We can make wireless network virtualization as a service oriented, containing many new elements delivered over advanced 5G infrastructure, that is, virtualizing the networks for everything as a service. In this, we will see about 5 types of services delivered over advanced 5G infrastructure: data and knowledge as a service, computing as a service, radio access network as a service, cache as a service, and energy as a service. The first is data and knowledge as a service. The vast amount of data is collected and sent over wireless networks frequently. Here, we propose to process this data locally, and only the necessary information is centrally collected. Second is computing as a service. In some cases, computing resources are dedicated to a particular application, which may prevent the full utilization of computing resources and lead to an energy and cost inefficient networks. Here, we are providing an on-demand access to computing resources. The third, wireless infrastructure and resources are the basis for all kinds of network operation. So, here we consider Cloud RAN, where all the RAN functionalities are centrally operated. This in turn can be viewed as 3 subtypes of services, which are infrastructure as a service, radio access as a service, and radio resource as a service. The next is cache as a service, which will be helpful for content delivery and big data analytics to store and process the data locally for data as a service. The last one is energy as a service. Few tasks can consume heavy energy. It can be offloaded to cloud servers with unlimited computing and energy resources. The birth of 5th generation 5G mobile networks bring both opportunities as well as challenges. We are going to discuss some of the challenges here. We need a standard protocol to express information sharing and negotiation handling in case of signaling. Allocation of virtual resources is considered to be complicated in the wireless network virtualization due to the changeability of transmission coverage, frequency channels, user mobility, and so on. Network management and deployment requires calls for proposals from algorithm and implementation for enhancement, data acquisition and abstraction, and some non-technical issues like model design. To realize better network virtualization for 5G, we indeed require a wide research on many possible constraint areas such as network and cloud convergence, wherein design of a metric to measure the radio and computing platform and to propose corresponding optimization methods. In case of big data analytic, we need to explore various tool capabilities for handling vast volume of data such as distributed caching, computing, quantization, and compression. The proposal and investigation for energy and cost efficient service composition. In short, 5G would be something that the communication world is looking forward to. Of course, nothing is free in this world. With all the hardships and roadblocks we have, to realize and provide this service for all the users, wireless network virtualization would be the best and most lucrative solution. Thank you.